So a very warm welcome. My name is Liz.
I'm Charlie.
And we are members of the NRICH team based here in Cambridge. We should begin by giving Trinity College here in Cambridge a big thank you. They fund our webinars so that they're free for you to participate, and we really appreciate that. Perhaps you've joined one of our webinars before. But if you haven't, everybody is very welcome. We have just, in fact, this marks the end for primary webinars, marks the end of a series. So we're quite excited to have reached this momentous point. And I think just to give you a bit of an overview, what I might do is share the NRICH website, because it will, I think it just helps give us a bit of an overview of where we are. Let me get rid of that Zoom window. So here we are on the primary teacher homepage. And those of you who have joined webinars in the past will know that we have been focusing recently on webinars to support mathematical thinking skills. And so we have completed 5 webinars focusing on each of our mathematical thinking skills. And this brings us today to the end of our 4th webinar for primary practitioners on developing positive attitudes. And just to give you a little bit of an overview, I'll click there so you can see we are the 4 mathematical mindsets or attitudes that we have identified here at NRICH are encouraging learners to be curious, so really tapping into that natural curiosity. We want to encourage them to be collaborative, recognising the benefits of working with others. Resourceful, now that was the webinar that we completed in May, which brings us to today's focus, which is on supporting students to become more resilient. Now, what we thought we would do is we've both been reading quite a lot about resilience and related ideas, and we're really quite excited to share our reading with you, because we think it will really help you support your students. But what we thought we might do to start with is to give you the experience of being a learner, and so that we can talk about resilience from your point of view as a learner to start with. So to that end, Charlie, is there anything you wanted to add to introduce before we get going?
No, other than, we might have been in previous webinars thinking about skills, and I'm sure we've talked about conceptual understanding and so on. But even if you've got all those in place, if your students don't have a positive attitude towards the subject and a positive attitude to learning the subject, there's a really good chance that all the other work is sort of slightly wasted, because they feel, if they're feeling negative, they're not going to be willing to have a go at things. So we think this is really important.
Absolutely, yeah, thank you. That's sort of the our students' attitudes, mindset is sort of the fundamentals beneath which everything else sits. Okay, so let's go to a page. We've got a tab already open with this problem, and so remember we've chosen this because we'd like to put you in the position of a learner. So we hope you can see our number jumbler. We're going to invite you, please, to choose any 2-digit number, and we'd like you to add together the digits that it contains. So, for example, if you have chosen the number 42, you would be adding together the 4 and the 2 to make 6. And we'd like you to then subtract the total of the digits from your original number. So in my example of 42, you'd be taking away 6 from 42. And then you are left with a solution, an answer. And if you could find that answer on our number jumbler chart here, so find the result of your subtraction and look to the right of that number, and you will see a little symbol. And we'd like you to focus on that symbol, please. Focus very hard.
Yeah, you're going to jumble them up in a second.
I'm going to jumble them up.
So you're going to have to remember what the symbol is.
Yep, absolutely. And Charlie's been very particular to use the words jumble up, given we've got a number jumbler, because I keep using words that are not so helpful. Right, so let's see what our number jumbler does. Oh, wow.
Oh, I was thinking of a star.
I was thinking of a star too. Okay, interesting. I wonder, what were you thinking of? Please do post in the chat. Nice, Christine, Rebecca. Oh, okay. Well, do you think we all started with the same number? Should we not have given an example? Do you think people have just used 42? Okay. What is your gut reaction now? Could you express your gut reaction on the chat, please? Be as honest as possible. Oh, nice. Bernadette has expressed she thinks the interactivity is very clever. Kristen's shocked. Bernadette, I like this. Bernadette, how? 3 question marks. I think 3 question marks are important. And I think your reaction would mimic the way that students might react too.
And actually, in a classroom, it's even more dramatic because you might say to the student, "Can you put up your hands if you also saw a star?"
Yeah.
And then all the hands go up, and they look
like,
around.
Oh, yeah.
Yeah.
Okay. So I guess we could think now about a question you might have. Just to answer this, so we're looking at the number jumbler problem. If you've just joined, you should be able to see the URL at the top. What we would like you to do now is have a little think. So at this point in time, what might you like us, as in Charlie and I, as the teachers in inverted commas, what would you like us to be doing next? What do you want from us at this point? Thank you for posting the link, Charlie.
Yeah, because many students might look at that and think, "Oh, I've got no chance of understanding what this is all about."
Magic.
And maths has always been a mystery to me.
Yeah.
And I'm going to go out and play tennis,
Right.
Go and talk to a friend or something.
Right.
What can we as teachers do to support our students so that they don't give up?
Yeah.
What might they need from us so that they carry on behaving like mathematicians?
Absolutely. Yeah, that's a nice way of phrasing it. Okay, we've had a few suggestions so far, but let's give you another moment. So you've come up with some really useful comments here.
And really importantly is that nobody has suggested giving up. Everybody has suggested the kind of strategies that reflect a positive attitude, a growth mindset, perhaps.
Yes.
A willingness to engage with the problem for a bit longer.
Absolutely.
Now, that might be because we tapped into your curiosity,
Could be.
which was one of the mindsets. So choosing the task carefully seems important, because then our students are much more likely to want to carry on if they are genuinely curious. Sorry, I interrupted.
No, it's fine. So there have been a number of suggestions, all of which are really useful. Some of you have said, "Oh, I want to see the chart again. I want to see I want to have another look. Really good, and that's really nice, because that's something that as a teacher I can do. I'm not doing any thinking for you at all, but you are recognizing that could be useful. So that's one thing. Many of you are saying, I want another go. Can we do this again? And I think absolutely it would be really useful. So we will do it again. I just wanted to, and I think when we do it again, I'll be able to address one of the concerns on the chat, which I have clocked. So and some of you are actually beginning to think, you're actually beginning to express some conjectures, which is lovely. So we've got you hooked into the mathematics. But okay, Charlie, so as the teachers, shall we give everybody a chance to have another go?
Okay.
And in doing so, we're going to show you, to do that, we'll click try again. So here is the grid. Let's have another go. And I think this will bring up a few interesting points as a result. Right, so choose a 2-digit number. We might suggest you try a different one that you did the first time, but it's up to you. Add together the digits of the 2-digit number.
So you tried 42 the first
Yes.
time. And if I was to try 42, then add the 4 and the 2, get a 6.
Yep. Subtract the 6 from the 42. So subtract the sum of the digits from your original number, and then find the result of that subtraction on the grid and focus carefully on the little symbol that's to the right of the answer. Focus, focus, please. I'm going to jumble up the numbers. Let's see what the number jumbler does this time.
So it was a star last time.
It was a star last time. Ooh.
Cherries.
Ooh. Cherries this time. So that wasn't the same as the star. It's useful that you reminded us it was a star last time, Charlie. And I think that possibly that caused some of you a momentary sense of discomfort, perhaps.
Did anybody else get cherries? Just put in the chat what you got.
Yeah, let's just check. Thank you, Jennifer. Yeah. Oh, so nice. So some of you are using some conjectures that are already, you've noted some conjectures that others had, and maybe looked a bit more carefully at the grid as a result. Interesting. Okay. So Charlie, we've had a couple of goes. And so now, what we'd like to do is we want to, like you said earlier, we'd like our students to hang on in there. We don't want them to walk away, but we don't want to do the thinking for them.
Because there were some teachers who wrote, how, why.
Right.
So we still haven't answered that question.
We have not got anywhere near answering that question, have we? So perhaps as teachers now, we can make a suggestion about what we could do now. What we could see from the chart that there were different symbols. So not every number had cherries. That so there's clearly something that is common with the numbers we're getting. Something is going on here.
Well, I suppose if we want our students to be resilient,
yeah.
Some students will be capable of working on this on their own and happy to work on their own and struggle for quite a while and so on.
Yeah.
But I suspect many of us might feel slightly overwhelmed by this problem.
Yes.
Primary age students in particular, 9, 10, 11-year-olds, but even some secondary age students might look at this and think, well, this is a complete mystery, I don't have a chance.
Yes.
So one thing that we can do is encourage them to work collaboratively.
Yes.
We want to create a community of mathematicians
Mhm.
who struggle a little bit,
Mhm.
feel comfortable with a bit of struggle, but support each other.
Mhm.
So one of the things we could do is we could ask everybody to tell us what number they ended up with
Yes.
when they did the subtraction.
That's an excellent suggestion.
And perhaps if we were in the class, we might write them all down on the board.
Right on the board. Okay, well, let's try that.
Shall we do that? Shall we
Good idea.
share?
So could you please post in the chat, what number did you get as the result of your calculation? What was it? Which number were you looking at, and which had the cherry symbol alongside it? So we've got a couple of 54s. We've got a 45. I'm just going to share instead the visualizer we've got here. So Charlie is very kindly beginning to record. So 45, sorry, I've now missed the chat. 27, we've got a 27, we've got a 36, we've got a 9. Okay, those are the examples we've got so far. Charlie, I notice that we've got a 48 here. Kirsty, could you tell us what calculation you did? What was the number you started with, please? Would you mind just responding in the chat? Sorry to pop you on the spot.
And
We'll
for everybody else,
Mm.
perhaps you could start with a slightly bigger number so that you end up
Good
with
idea.
a bigger number. Because I think it might be possible to end up with some numbers, some answers. Because if you start with a number in the 70s or 80s or 90s,
Oh, Kirsty, thank you. You've posted the number you started with. Brilliant. And so you ended up with 36. Thank you. That's really helpful. Thank you. We've got 36 on the list. Charlie, you've done some, well, and we talk about that in a moment. Yes. Can we get any larger examples?
And is there an example which is larger than 9 but smaller than 27?
You've left a mysterious gap. Oh, a couple of people posted 81.
Yes, because if you start with a number like 91,
Yes.
91 ends up to 10. I'm making my subtraction as easy as possible. And 91 minus 10 is 81. Yes.
Yeah. Yeah.
I've left some gaps here.
Oh, yes. And somebody has clarified that they got 81 by doing 98, take 17. Bernadette suggested 72. Thank you. Oh, yes, we've got a 45. I think we've got a 45 already. Brilliant.
Can anyone find a starting number that then ends up larger than 54 but smaller than 72? Should we do the January, February, March as well?
Yeah.
Somebody ended
SB
up
is suggesting that if you start with 77, you end up with 63. So, and Rebecca, thank you. You've also suggested, so we've got a 63 there. So I wonder, are there any other possibilities? You know,
bigger than 81,
bigger than 81 or
between 9 and
27? 9 and 27. Thank you, Shabangi. That's another example of 27. Brilliant. Yeah. Jennifer's just, we've got a few assertions of 18. So yes, some nice examples there. 21, take away 3, 23, which is done, take away 5. Thank you. Anything bigger than 81? Milu, I'm sorry if I'm pronouncing your name incorrectly. How might you get 90?
What number did you start with?
What number did you start with to get 90?
And finish, yes.
If you could give us the calculation. while we're just pausing on that, Charlie, I think what is very significant is the way that you structured your gathering together of our results. So you very deliberately, I imagine, positioned the solutions that you were getting in numerical order. So you have, again, you've not taken away any thinking from us, but you've made it much easier for us to identify what's the same, what's different about these numbers, and for us to begin to notice patterns.
Yes, and I suppose I've modeled a good mathematical behavior,
Absolutely.
which we've addressed in a previous webinar when we were talking about working systematically.
That's right.
And of course, I could have just mixed them all up
Yes.
and asked, what might a mathematician do next? So perhaps I have done a little bit of the thinking for my students, and I might want them to suggest that writing them in order is suitable. But then that would take up a bit more time. And
Yeah.
but I think us modeling good mathematical behavior is really important.
It's really important. So I guess at this point, we might ask students in the classroom what we notice.
Yes. Yes.
So what do you notice about the results of our calculations? So Prabha, I'm sorry if I'm not pronouncing your name correctly. You are absolutely correct. These are all multiples of 3. I guess there are quite a lot of multiples of 3 that aren't on the list here. So perhaps the suggestion they're all multiples of 9 is useful to notice here because we aren't missing very many multiples of 9 which are 2 digits.
Okay. Yes.
Don't worry, I wasn't going to say any multiples of 9, full stop.
Yeah. Yeah, there are no gaps between 9 and 81, which
gaps between 9 and 81, where there are quite a lot of gaps of multiples of 3. So although you're absolutely correct, Prabha, perhaps multiples of 9 gives a more precise indication of what these numbers have in common. Yeah, thank you. And so I mean, for some, it's tempting, Charlie, isn't it, to leave it there?
Yes, but this hasn't explained what's going on here.
Absolutely not.
And I don't think if I'm going to give this to my students to work on, I do need to again model mathematical behavior, which is right. I want to understand. So the curiosity is that willingness to make that extra effort to try to make sense of this. So it's up to us to give students interesting problems that tap into their curiosity.
Yeah.
Make, they've got to be comfortable with the idea that they're going to work on something which seems still difficult to understand.
Yes.
Hang on in there, but they're being supported.
Yeah.
We seem to be getting some insights, which is really nice.
Yeah.
So what could we do?
Yeah.
Well, I suppose one possibility is I ask you all to start with a number in the 20s.
Okay. Yep.
So can you all please start with either 20 or 21 or 22, all the way up to 29, and maybe choose 2 or 3 numbers in the 20s and do the operation that we've been doing where you add the 2 digits. So if you start with 24, you get 6, then take it away from 24. Just see what happens when you start in the 20s. And then post something in the chat.
So we've got some agreements. Every time we get 18, answers will always be 18, always end up with 18, 18 every time. Ruth has given a particular example. Thank you. So we're starting with a number in the 20s. Yes, that's a bit better. Thank you. And we're always getting 18 as the result. Yeah.
What do you think will happen if we start in the 30s? So one of the things that we talked about in the previous webinar was this idea of conjecturing. Could you post in the chat what you think might happen if we start in the 30s?
We've got several suggestions. Try to discipline yourself not to do any calculations. What's your conjecture? Nice.
Okay, and then can you check? Can you confirm whether you were right or not? We're sort of labouring the pointer here a little bit, but I think these are important stages for students to go on if they're going to feel that they're sort of in control. And
yes, and yeah, in control, but also
well, they're learning something new.
They're learning something new. They're not. It is demystifying. I think that which is really important. Okay, so we've got some examples of ways to get 27.
Okay, so if you're a January, February or March birthday, I don't know, start in the 40s. If you're an April, May or June birthday, start in the 50s.
Yeah, okay.
If you're a July, August, September birthday, start in the 60s. If you're a October, November, December, start in the 70s. And don't worry about the 80s and the 90s for the time. And just make a conjecture and then check it.
See what happens.
And we'll keep a record here. And then in the chat, write down what you started with and what you ended with.
Yeah. So we've got a few suggestions already. Thank you. This is really nice. Thank you. So, Charlie, do you want some suggestions?
Yeah.
So we've got suggestions that if you start with 40s, we're going to get to 36. If we start with the 50s, we're going to get 45, 60, sorry, 54. 70s, 63. And I think that's fine. I don't think anybody's done 80s, have they?
No. But do we have a conjecture about?
Well, some people have conjectured. We've got a conjecture here. Will always be the multiple of 9 in the previous 10.
Right. Okay. So that's a new realization that we didn't have before. So we're getting all the multiples of 9, but somebody is saying that 18 here is 2 9s.
That's right.
27 is 3 9s.
Yeah.
36 is 4.
Yeah.
And we hadn't thought about it in that way.
We hadn't at all. All we'd done was notice that they were all multiples of 9, but we hadn't done such a precise conjecture.
So this is 2 9s, and we started in the 20s.
Yeah.
This is 4 9s, and we started in the 40s. This is 7 9s, and we started in the 70s.
Yeah. This feels like we're onto something here.
We're on, yes, we're drilling in, we're honing.
Yeah.
Now, Liz, you and I have had some experience of working with teachers who sometimes do things on the board but don't add a commentary to it.
Yes.
We talk about using, silence.
Silence.
And I just wonder whether I should try.
I think that'd be really useful. So with this, Charlie's going to scribe, but he's not going to explain what he's writing. We'd like you to watch what he's doing. See if you can unpick what's going on. This is a chance for you to make sense of the mathematics.
Because we're wanting to explain this, that somebody noticed. Somebody said that you always end up with 9 times.
Yeah, it would always be the multiple of 9 in the previous tens. Right. Is the way that.
Okay.
Tasha, sorry if I'm mispronouncing your name.
Okay, so here we go. If I start with 41.
Don't say anything.
Oh, thank you. Okay. I'll do one more example.
So in the classroom, I think we would now suggest that students turn to each other to talk about what they have just seen. Can they, thank you, Ruth. Can I make sense of this? Can I add my commentary? Can I work with my partner to add a commentary? How does that help shed light on this problem?
I was going to use shed light as well.
Were you? Yes. Okay, good.
Does this shed light on why we ended up with multiples of 9?
So we appreciate that you haven't necessarily got anybody to talk to with you right now, but perhaps you could just have a think and articulate as best you can in the chat, please. That's a bit better.
Oh, that's a lot better. Apologies, it hasn't been
Oh, that's much better, yes.
quite in focus.
Yeah.
Do you think of that as 4 10s or 10 4s?
Personally, I think of it as 10 4s.
Oh, so I did the wrong thing writing.
I this personally.
Oh, but 10 times 2 could be 10 doubled, or 10 lots of 2. Yeah. Maybe this is a good time to stop, Liz.
Yeah.
I can imagine with a class, I mean, we've been working with some primary school teachers who are working on oracy.
Yep.
And getting students to articulate their thinking,
Yeah.
to rehearse what they're thinking by talking to their neighbor, and then talking to the whole class. And beginning to articulate what's going on in a way that reflects their understanding. Eventually saying something along the lines that Shivangi was talking about, where you're talking about, well, I can add the digits and subtract that, or it makes no difference if I subtract each digit separately.
Yeah.
And if I subtract the one that's in the units column first, then I'm left with no units. So I end up with a multiple of 10.
That's right.
And it's going to be 10 times whatever's in the tens column. And then if I take one of those away, then instead of having 10 lots of that, I can end up with 9 lots of that.
Yeah.
And so I'm showing some understanding about place value.
That's right.
And all of a sudden, something that felt quite mysterious begins to make sense.
Absolutely.
Yeah. And at several stages in this journey, students might have given up and thought, well, this is too difficult to understand. I can imagine, I think I've given this problem to adults who said, no chance, I've just walked away from it.
Yeah.
And these are adults who are very competent and capable in the outside world,
right?
Got jobs and all the rest of it,
yes,
but feel very apprehensive about doing something like this.
Yes.
And so our students are going to feel equally anxious unless we give them the support, the kind of support that we've been giving.
Yes.
Okay, oh, I'm not going to stop sharing.
No, I think maybe staying sharing the visualizer. What we'd like to do is that we've offered you a mathematical problem that we hope has demonstrated, has put you in the position of the learner, to give you a feel for the kind of strategies that for you as a teacher might use to help your learners continue with the problem, not to give up, not to walk away. We want to kind of take a step back, if you like, now, and think about Charlie has been reading
Sixth Symphony
Thank
High's
you.
thoughts about flow.
I haven't perfected how to pronounce the name, unfortunately, yet. So I'm glad you did
I've
that.
got a crib sheet that reminds me.
Good.
And I, having heard him talk about flow, I'm interpreting what he's saying. I'm going to try and interpret what he's saying
Yeah.
in a very simple diagram.
Okay. Yeah.
So we're going to imagine a chart like this, and if you can move along the horizontal axis, you are increasing the level of challenge. So not very much challenge. Sorry, oh goodness. Not very much challenge here, lots of challenge here.
Yeah.
And on the vertical axis, I'm going to think about skills. Skills required, I suppose. And again, not much there and a lot more there. And I'm going to split this up into 4 sections. So here we're not being challenged, and it doesn't require much skills.
Yeah.
You know, I'm sitting like a couch potato watching something on television,
So
which
mindless.
yes.
Yeah.
Whereas here I might not be challenged, but I've definitely got more skills than are required to do this. On the other hand, here the level of challenge is very high.
Yes, but I'm not equipped.
Yes, my skill set doesn't match what's required.
Yeah.
Whereas in the top corner, which is what Sixth Symphony High talks about as being in flow, is where the level of challenge matches the skills that I've got.
Right.
So he talks about what one can imagine in this section here, one's a little bit apathetic. Apathy and boredom
Yes.
prevail here.
Yeah.
I'm not doing anything challenging or
Yeah.
engaging.
Yeah.
Here, the challenge is not high. I've got many more skills that I need.
Yeah. So
I'm doing something. I feel very comfortable.
yeah, sort of cruising almost.
Yes.
Yeah.
Yeah. I'm in control, relaxed. I suspect that neither of these leads to very much learning.
No.
So we wouldn't want our students to be spending very much time here.
No.
I do want them to get to the stage where they're beginning to do something in a semi-automatic way, where they're feeling comfortable, but they've done some learning before to build it. This one here is quite worrying. Students might feel very anxious.
Yes, if I'm being given far too much challenge for the skill set that I have, yeah, I'm going to be, I'm going to be worried. I'm going to have nothing to offer this situation. Yes.
And so we don't want our students to be in that position.
Definitely not.
They're going to panic, and in order to move them into what Sixth Symphony High talks about, flow, we're going to have to increase the skill level. So this definitely leads to learning.
Yeah.
There is a need to do something.
To introduce more skills.
So this is where if you're in flow, you're intrinsically motivated. It's rewarding. You've got some control. If you succeed, then you sort of increase your self-esteem. So you've had to use your skill set. You're being challenged, but the challenge is within your grasp.
Yes.
Of course, if you are in the comfortable, relaxed zone, you can also move that way, but that involves a decision to increase your challenge level.
Yes.
And most of us feel quite comfortable not being challenged too much. So what Sixth Symphony High says is we're much more likely to learn because we want to get out of this
Because
bottom
we're
right.
anxious. Yeah.
Whereas here in the top left, it's the teacher who might notice that we're not being challenged sufficiently.
Yes. Yes. Yes.
So in terms
Yeah.
of what we did with Number Jumbler,
Yes.
we were challenging you, but we tried to avoid you being here. So we were sort of working into that direction where we were getting you to do the thinking as much as possible.
That's right. And this chimes very nicely with this book, which some of you may have come across. I'll put under the visualizer. As you can tell from the title, the authors are American. Productive Maths Struggle. So what the authors of this book are saying is that so I would suggest that the productive math struggle equates to this area of Charlie's diagram. This is when you're in the flow. So as teachers, students will only learn if they are having to make sense of some mathematics for themselves. They will, oh, good, Kristin's clearly read the book. If you're being asked to grapple with some mathematical ideas, to bring some of your own experiences, then you are going to be learning. So what the authors of the book suggest is that it is our responsibility of teachers, as teachers, to create productive struggle for our students and to make it very clear. So there are I guess many aspects to think about. The first is that
you want to put yourself in the camera.
Yes, if you insist. So the authors suggest that it is if we want students to learn, we need to plan for productive struggle. And the first thing we can do is make it very clear to students that we expect them to struggle. So this is a normal part of being a mathematician. So set the scene in that way. Then I guess it's about choosing the tasks carefully, which, the more you get to know your students, the easier that becomes. So choosing the task carefully then allows you to actually plan to support students with their struggle in the moment. And there are two aspects of that, I think, Charlie, aren't there? That there's the aspect of general support with struggle. So go on, you better something. We will point you in the direction of the guidance we've written on the NRICH site in a moment, but we've tried to do both. We're trying to do both these things. So one, in a more general sense, how can you have some general questions at your fingertips, some general strategies, so that in the moment in a maths lesson, you can prompt students, for example, something as simple as what have you tried so far can open up a conversation, or can you record something that you've learnt so far, or can you try and articulate what you're struggling with? So that's a bit more of a general strategy. But then as a teacher, you might also think of some task-specific strategies to help students in that moment of struggle, giving them scaffold without doing the thinking. So that comes back to, in our example of Number Jumbler, something like Charlie did, organising the recording, for example. Shall we, I'm aware we're about to run out of time. Shall we go to the NRICH website, Charlie?
I'm aware that one of the things you said,
yes,
where you build up a culture where there's an expectation that part of making progress, learning new things, involves being stuck at some stage.
Yes.
And it reminds me, Matthew Said, in his book Bounce, talks about, okay, what is the criteria for becoming, one of the criteria for becoming a world-class ice skater?
Yes.
And most of us think, oh, lots of practice and so on.
Yes.
And so on.
Yes.
But he said it's a willingness to fall 1,000 times,
right,
at least 1,000, and then get up. Because all the top ice skaters have challenged themselves and they have moved from that top left-hand corner into flow by increasing the level of challenge. They knew they weren't going to win any medals if they just skated round and round without doing some jumps and twirls and whatnot. And so, but in order to get to that, they've got to accept that they're going to fall at least 1,000 times
Yeah.
And
Yeah.
I'm not sure that we share those kind of messages and stories enough with our students.
No.
And I often talk about WD-40.
Yes.
WD is what you use on rusty bicycle chains and locks and so on, and it stands for water displacement. And the reason it's called WD-40 is that WD-1 wasn't very good. WD was a little bit better, perhaps, but still not very good. And they kept improving and improving and improving. WD-20, WD-21, WD-39 was almost perfect, but not quite right. And then they got to WD-40. And so it took 40 different formulas to get there.
Yeah.
And I think a recognition that this is part of what we're going to be doing in the maths class is really important.
Absolutely. So let's, just before we go to the NRICH website finally and point you in the direction of resources that we hope will help. Here we are back at our primary teacher. So I'll just rehearse what we did. We went to the primary teacher landing page. We clicked on this third box, which is developing positive attitudes. And we're focusing on being resilient. So I'm clicking on that box. And so the first thing on this page you will note is that we have a link here in the blue box to a guidance page. So I'm going to just go to that quickly. Here we have written some guidance, some practical advice about how you can support students to become more resilient. We will be adding to that over the coming week or two. And what our aim is to do exactly as I was just describing, to help you with some strategies generally, but also to think about some task-specific strategies and the way that some NRICH tasks help students hang on in there. So we will, and you can see already some examples of those, but we will be adding to it over the next week or so. If I just go back, the other thing to notice on this Being Resilient page, of course, is our link to tasks. So there are some tasks here which are linked to curriculum objectives for each year group, but we feel offer opportunities in particular for you to help students become more resilient. It might be because a problem requires quite a lot of thinking to really get to grips with. It might be that there's an element of finding all possible solutions, which is something that students often find tricky and give up on quite easily. But we hope that those are useful examples as a starting point. We will put up a recording of today's webinar at the top of that guidance page in case you want to share it more widely.
Have you said that you can also get at this through the problem solving schools?
We haven't. Thank you, Charlie. Your school may be a member of our problem solving schools project, and even if you are not yet, you can find a link to all the guidance very easily through the resources and professional development page here. Let me just make that a little bit smaller again. So here are the 5 mathematical thinking skills that we alluded to earlier. Clicking on each one takes you to guidance and linked tasks. And here we are.
And the recordings of the webinars.
And to recordings of the webinars, sorry. And here we are on the mathematical mindset. So everything that I've just showed you can also access through this link here as well.
And if you've missed previous webinars, you can also access them by going to the other 3 boxes.
Absolutely. We very much appreciate your participation today. I'm just going to pop a link to the feedback form in the chat. We would really appreciate you filling this in, please. It really helps us do better next time and to give feedback through our funders to Trinity College, as we mentioned earlier. The scrambling activity, Bernadette, is called Number Jumbler. We can post the link here. There we go.
And somebody asked me about Matthew Said's book.
Yes.
We will include that in the reference notes at the bottom.
Yes, on the guidance page.
Yes.
Yeah. So thank you again. We hope this has been useful. Well, please do keep an eye out. We'll be putting we're thinking about the webinars that we're going to be organising for the next academic year here in the UK. Our academic year finishes in a month or so. So we will be offering more webinars come the autumn. So look out for those on our events page. Thank you all very much and have a good rest of the day.
Hope that was useful.